On Being a Scientist is the title of today's presentation, and as I mentioned, it came from the title of the publication of the group from the National Academies of Science and Engineering and the Institute of Medicine. And this was produced a few years ago at a time when there were a number of highly publicized cases of alleged or actual scientific or research misconduct. The feeling was that what had been inculcated into people by just habit and teaching over previous decades needed to be formally introduced to people who are entering the scientific disciplines. And so this group of eminent scientists got together and came up with the document, which is supposed to be distributed to people in graduate school, undergraduates, and people who are working in science. And we are going to talk today about science and what it means. Now this is, I showed this at last week's talk on human subjects, but it's the public perception of science as fostered by the media and in particular by Hollywood. And it's a Gary Larson cartoon in which the teacher is saying, it says, in their final year, all research scientists are required to take one semester of maniacal laughter, and the teacher is showing the class how to develop the appropriate muscular skills in order to sound like a mad scientist. And that is one of the things that science has to combat, the perception that it's an enterprise that's being run by madmen. And the reality is somewhat more prosaic and mundane. It's really an enterprise being run by regular people who are doing things in a different way from the way that most people conduct their lives. What is science is the first question to address, and it's an important question because science is not like what we normally do in the everyday course of our lives. It's what scientists do is the sort of trivial answer, but it actually has a certain profundity to it, because scientists do science and they don't do everyday living. Science is a discipline which is somewhat distinct from the way we conduct our everyday lives. Our everyday lives are conducted in a situation where feelings and emotions, interpersonal relations, hunches, beliefs, unsubstantiated beliefs, rumors, and the like govern much of our everyday interaction with other people and our decisions that we make with other people. And science, on the other hand, attempts to remove these subjective and non-rational bases of making decisions and tries to develop a rational framework by which they can look at one can look at nature. The definition in the dictionary is that science is the accumulated and accepted knowledge which has been systematized and formulated with reference to the discovery of general truths or the operation of general laws. That is a rather dry description of what science is, but it pretty much covers it. And the notable feature of it is that there is an attempt to be systematic and to formulate general laws and general truths about the way things work. It's not based on superstition, it's not based on religious belief, it's based on observation and systematically attempting to understand what you're observing. It's based on carrying out experiments, on testing hypotheses, not on hunches and beliefs. And the basis of science is something called the scientific method. And the scientific method is something that's been around really just for about 400 years or so. It arose in its most recent form at the time of the Renaissance, and it was then elaborated and developed over the succeeding centuries. And the fundamental part of the scientific method was thought for many years to be something called inductive reasoning, which was the concept of reasoning from the part to the whole, the idea that by reducing things to their simplest elements, by studying them carefully, one could induce general knowledge and general laws about the way that nature worked. And this was originally promulgated by Francis Bacon in those odd moments when he wasn't writing Shakespeare's plays. And it was the way that scientists believed that they operated for the past 300 years. Early, and this is perhaps a cartoon demonstration of the way the inductive method is supposed to work. And it says here, there's a lot of formulas, and then a miracle occurs. That's where you induce the law that you're looking for. And then there are more formulas, and the professor's saying, I think you should be more explicit here in step 2. And that was always the problem with the concept of the inductive method, that at some point the idea of rational science went out the window, and you took a flying leap into the unknown and came up with a formula or a law that arose from all these individual observations that you had made. It was in the early 20th century that Karl Popper, who was an Austrian, proposed an alternative concept of the way that science works. And his concept was the concept of falsifiability. The idea that you don't actually ever prove a theory to be true. What you do is you constantly challenge the theory and attempt to disprove the theory, because there is an essential asymmetry between proof and disproof. You can conduct experiment after experiment trying to prove something, and if you always get the results that you're anticipating, then you nevertheless don't have any greater confidence that what you're looking at is the truth. Whereas if you conduct an experiment which contradicts what your theory is, then you have in that one experiment falsified the truth of the theory that you're attempting to look at. And so the idea of falsifiability is the fundamental notion that has become the basis of science in the past century, that the way you're doing science is not trying to prove something, but always attempting to disprove it. And the more resistant your theory, the more robust your theory is to disproof, the greater the confidence you can have in it. But it also has the downside that it suggests that all theories are essentially provisional, and that any one of them could fail at any time. And you know that's probably true, because as we discover more about nature, we have to modify and rethink the way that we understand nature. Proving is often, proving means to test something. It's not to actually show something to be absolutely true, but to test it. And that is shown in the phrase, it's the exception that proves the rule. You're not proving something to be true by looking at the exception. You're testing the rule that you've developed, and that's the concept of falsifiability. So, characteristics of scientific inquiry. I have to apologize that my laser pointer doesn't appear to be working, so you'll have to bear with me as I just go down the list without the assistance of a little red dot that's bouncing up and down on the screen, but perhaps that's a good thing. Scientific inquiry consists of developing carefully controlled experiments with defined objectives. If you don't have a controlled experiment, then you may very well be wasting your time, because you have no idea of knowing whether something that you haven't controlled for isn't influencing the results that you're obtaining. It's the accumulation of data in a careful and objective fashion. The idea that you can pick and choose your data is very alluring to politicians, but it's something that shouldn't happen in science, that you have to accept what you get, whether you like it or not. You have to record the data in a comprehensive fashion, because you never know what it is that you are looking at that might or might not be important, just because you don't realize it's important at the time, so you record everything. You develop a hypothesis based on these data, and then you test the hypothesis by using it to predict additional phenomena. You can develop any kind of hypothesis you like, but if it doesn't have the utility of predicting something that you haven't looked at yet, then it's really not a terribly useful hypothesis. People can come up with all sorts of hypotheses that really go nowhere beyond the actual hypothesis itself, and are therefore kind of useless things to have around. The idea of modifying or discarding your hypothesis if the test does not correctly predict the outcome is something that non-scientists find really difficult to understand. People who, for example, espouse a belief in UFOs will not be amenable to having their belief in UFOs contradicted by observable evidence. They will constantly modify their belief, but they will not discard the hypothesis. The scientists must be willing to accept contradiction by empirical data. Same thing applies to ufologists. They should be willing to accept contradiction, but are usually not. They must be willing to discard or modify the hypothesis if confronted with data that do not fit. And the classic example of that is the theory of gravitation, which was developed originally by Newton, and which held sway for 250 years until data accumulated which suggested that the Newtonian idea of the universe could not explain every observable phenomenon. And what happened was that Einstein incorporated the Newtonian view of the universe into his own view of the universe. And so that the hypothesis was not discarded but was modified in order to accept the data that previously did not fit. Another characteristic of scientific inquiry is that you publish your data. You send your data out to others to look at, to critique, to offer suggestions, to point out the flaws in it in order to strengthen your findings. And also in order to increase the pool of generalizable knowledge, the idea that somebody else might want to know what you're doing. So the concept of the mad scientist working in solitary splendor in a rooftop castle is really not the way that scientists work, as we all know. The publication of the data is also useful in that it allows somebody else to replicate it. If you publish data without sufficient detail to allow someone to replicate the data, then you're doing science a disservice. The idea is that somebody else should be able to take the information that you provide them, go through the same steps you did, and come up with the same result. And that's another aspect of science that differs from non-science. But as in every field of endeavor, science is a human occupation, it's a human preoccupation, and it's done by humans. And humans are flawed individuals and are subject to all sorts of pressures. And these pressures can manifest themselves in research misconduct. And so I wanted to talk for most of the rest of the talk about research misconduct and how, as an institution and as a society, we have to deal with research misconduct. Because every case of research misconduct that is publicized tarnishes the image of all the rest of us who do science and do it honestly. And it's useful to be aware of what can go wrong and to be aware of what constitutes research misconduct and how it's handled by the institution. And there are a number of notable examples of research misconduct that have occurred in the past 20 years or so. Summerlin was an investigator at Memorial Sloan Kettering in the East, who was looking at transplantation of skin from one mouse to another, and was attempting to show that he could suppress the rejection that would normally occur. And in order to make his transplantation experiments more effective and more spectacular, he was transplanting black skin onto white mice. For whatever reason, the pressure to publish, the pressure to show a positive result, Dr. Summerlin ultimately was found to be marking his white mice with black magic marker in order to demonstrate the effectiveness of his technique. And so clearly that's not kosher. Dr. Darcy was working with a very respected investigator on heart patients, and Dr. Darcy was making up his data wholesale, and what gave the lie to his data being false was the fact that he had improbably precise data. He was conducting clinical trials at which every patient made their appointments. No patient ever missed an appointment, which, if anyone here is doing clinical trials, knows is cloud cuckoo land. That when you're dealing with people are always missing appointments. And so that was what tripped him up. Dr. Bruning was doing multiple studies on psychotropic drugs in mental patients. It's not entirely clear how many patients he actually inflicted his studies upon, but he was fudging the data. He was making up data that when the results he got didn't fit, and he was ultimately exposed too. The problem there was that the person who exposed him, who was a colleague, was the one who, at least initially, suffered the consequences of his honesty. He was the one, the whistleblower, who got his grants cancelled and so on and so forth. That's one thing that I'll get to a little bit later in the talk. And then Dr. Slutsky from the University of California, San Diego, was a cardiologist. I don't know what it is about cardiologists, but they seem to be particularly prone to this. At least 2 out of these 4 were cardiology professors. Dr. Slutsky was turning out papers at the rate of 3 or 4 a week on research, and someone suddenly realized that, hey, wait a minute, you just can't do that. You don't have enough hours in the day to conduct all that research. And he was the subject of a very extensive inquiry that's become a model of its kind, conducted by a radiologist, Paul Friedman, at the University of California, San Diego, that exposed it. And what resulted there was that many of his papers were withdrawn, and retractions were published in the journals. Okay. As a result of these publicized cases, the government set about setting up regulations. And some people would say that this was an overreaction, but it's really difficult to argue that a little bit of fraud is okay. No fraud is okay, and if you have to set up regulations to tell people what is fraud and what's not fraud, then that may be the way that you have to go. But it was a long drawn out process in order to develop a definition of what constitutes research misconduct. But the current definition, as published in the regulations, is that research misconduct is defined as fabrication, falsification, or plagiarism in proposing, performing, or reviewing research, or in reporting research results. That seems like an awfully short paragraph to spend 10 years coming up with, but it pretty much covers it. The current definition: falsification, fabrication, and plagiarism. What does that mean? Don't cheat, don't lie, and don't steal. And that's basically it at its bottom line. Now, let's go over each of these in turn. Falsification is manipulating research materials, equipment, or processes, or changing or omitting data or results such that the research is not accurately represented in the research record. Altering data to eliminate or change the results to conform with the hypothesis being tested could include, but not be limited to, omitting data points to improve the fit. That's always very tempting when you have that one outlier, but unless you have a really good reason why you understand why that outlier is there, you just have to live with the fact that you don't have a perfect data set. Ignoring experiments that contradict a hypothesis, that's a difficult one to catch because people don't trumpet their failures or what they perceive to be their failures. And so selectively choosing the experiments that conform to your hypothesis is a rather insidious way of scientific research misconduct. And it's contrary to the idea of falsification. If you only look for experiments that confirm your hypothesis, then you're going to be led very far astray. Enrolling patients who do not meet entrance criteria, that can be, in clinical research, can be a no-no. The breast cancer study that was originated at the University of Pittsburgh had a problem there with one of their investigators in Canada, Linda, by the way, Canada, who was making up patients out of whole cloth. And clearly, the results of a clinical trial may have impact on thousands or even millions of people, and to have data in there that just does not represent real people subverts the whole idea of trying to find out what works and what doesn't work. And another form of falsification is manipulating the data, methods, or processes in order to achieve the result you're looking for. And again, that's the idea of not being willing to accept contradiction by the empirical data. Fabrication is making up data or results and recording and reporting them. For example, as with the falsification, creating patients and patient data sets in order to fill out your clinical trial, inventing the results of experiments not performed. Actually, this is easier to do than actually doing the experiment and then ignoring the results you don't like. This way you can get to come up with the numbers you really want to see without all the messy inconvenience of actually having to do the experiment, which makes it terribly tempting to some people. But fabrication also extends to the way that we conduct our business. It can extend to making up a resume with false information on it. If you're being hired for a position in science on the basis of your resume, then that resume ought to be accurate. People who record degrees that they never obtained, people that record publications that they never published, people that record collaborations with other investigators who have never heard of them, as a way of making themselves look better, are cheating other worthy and honest people out of a position that they might otherwise be eligible for. Another example of fabrication is listing collaborators without permission, putting a big name on there without asking them in order to make your paper seem more saleable. Plagiarism. Plagiarism is probably, although it's not by any means clear, the most common form of research misconduct. Some plagiarism is unknowing, unwitting, and subconscious, and some plagiarism is out and out theft. But it is the appropriation of another person's ideas, processes, results, or words without giving appropriate credit. That's the equivalent of making up experiments that you've never actually done. You're using somebody else's idea and not having to think yourself. That could be quoting or copying other person's writings without appropriate attribution, such as using another's language in writing a research paper, or using others' data in a research application and passing it off as your own. And both of those are not as uncommon as one would like. But you have to admit, if you've read 500 or 600 research papers, a felicitous turn of phrase or a felicitous way of describing something may very well slip into your subconscious. And I'm sure that all of us may have at one time or another used a phrase without realizing it. When it becomes wholesale appropriation, though, then it's unacceptable. Wherever possible, you should give appropriate attribution. For example, the cartoon that I showed a little bit earlier, I should have really given appropriate attribution to the cartoonist who drew it, and I think I probably will the next time I give this presentation, but I didn't, so I guess I'm guilty of plagiarism in that particular instance. Here's another case where I'm not going to give attribution. This is the idea of... what?
They're signed.
Yeah, well, it's signed, but can you read that? I can't read it.
That's his attribution.
Oh, okay, cool. This is the idea of honorary authorship, or authorship of for someone who had nothing to do with the project. The secretary is saying, I see you're the co-author of the paper, and you came up with some new insights in the field of quantum mechanics, which you'll explain further next week. And he's going, I did, I will. It's an insidious problem when people are involved in papers that they had very little to do with. Research misconduct formerly, in the initial iteration of the definition, included a rather invidious paragraph or phrase that says, in addition to fabrication, falsification and plagiarism, other practices that seriously deviate from those that are commonly accepted within the scientific community for proposing, conducting or reporting research. That was roundly denounced by the scientific community, because many of the greatest advances in science take place as a result of the acts of the mavericks who don't accept the conventional wisdom in science, who think about things differently, who think about things outside the box. So after a considerable amount of shouting and complaining from the scientific community, this was dropped from the research misconduct definition. But added into it was this phrase, research misconduct does not include honest error or differences of opinion, because everyone makes mistakes, and everyone in science has an opinion that may differ from someone else working in the same field. And that's part of the dynamic tension of the scientific process, is that you're constantly challenging each other to defend your particular interpretation of a data set. Also, what is not covered by the research misconduct regulations are authorship disputes. The government, although not known for being particularly bright, much of the time realized that getting into refereeing disputes between authors was a train to nowhere. They would get into more problems than any other form of misconduct. It does not include personnel issues, which are covered by human resources in general. It does not include human subjects violations directly. That's the responsibility of the IRB, or animal care violations, which are the responsibility of the Animal Care Committee. And it also doesn't include sloppiness and poor record keeping. Some of the best scientists are the poorest record keepers, and that's not to excuse it, that's just to point out that it's the case. Nobody is perfect, but we should all try to be. And one of the ways of ensuring that you have a useful data set is to make sure that you record everything in such a manner that it cannot be challenged as being made up after the fact. And so it's insurance on your behalf to make sure that your way of recording data is not subject in and of itself to criticism. So recording it on paper towels, or recording it on the back of your hand, or writing it down in a yellow pad and then ripping out a couple of pages in order to write some other thing is not a terribly good way of recording data. Data should generally be recorded in such a way that it's clear that it has not been altered. Or if you do alter it, to alter it in such a way that you can see what the original number or word or whatever was before you changed it. And this is the foundation of, in clinical research, of the good clinical practices that have been developed over the years, so that you can go back and look at the collection of data and show that, as far as can be determined, the data was collected appropriately. Okay, what happens when you get allegations of research misconduct made and there is a finding of research misconduct made? Well, the way that it's set up is that each institution is responsible for conducting a review of the allegation of research misconduct. And as part of that review, they have to determine a number of specific things. First, that there is a significant departure from accepted practices of the relevant research community. Second, that the misconduct was committed intentionally, knowingly, or recklessly. And third, that the allegation is proven by a preponderance of the evidence. And this is important. This last one in particular is important. This is not a criminal trial type situation where you have to prove something beyond a shadow of a doubt. This is something where if you show by a preponderance of the evidence, and that constitutes 50.01% of the evidence, then you have shown a finding of research misconduct. So we're not actually asking for absolute proof, or the government is not asking for absolute proof, but merely for the distinct likelihood that scientific misconduct occurred. Research misconduct is the responsibility and oversight of the Office of Research Integrity at the National Institutes of Health. And the Office of Research Integrity, which is its current manifestation, it's gone through a number of name changes, and it was originally in something of a degree of disarray when it started off, but now seems to have gotten its act together, is the agency which will oversee what the local institutions do when they are confronted with an allegation of research misconduct. And they have the right to step in if they feel it's appropriate and conduct their own investigation. Each institution which is federally funded has to submit an assurance of compliance, which is basically a contract that says this is the way we are going to do business. We are going to have policies and procedures in place. We are going to have a mechanism for conducting initial and then subsequent reviews of allegations of scientific misconduct, and we are going to have this or that series of penalties in place as well. The local institutional entity which is charged with dealing with allegations of research misconduct is the Ethical Standards and Research Committee. And that is a committee of faculty members with staff support, moi, who are charged with looking at allegations of research misconduct as they arise. And they have, as specified in the regulations, they have very strict timelines to adhere to. They can't allow an investigation to drag on for months and months and months as a way of stalling things. They have 60 days to do an inquiry from the time they receive the allegation. They have 90 days if they decide to go on to an investigation to do the investigation, and then they have to produce a report. Our Ethical Standards and Research Committee at the moment consists of these individuals. Dr. Nadel, who is a surgeon in private practice, is the chair of the committee. Dr. Koppel is the vice chair, and the members in the coming year will be Dr. Cassabury, Dr. French, and Susan Partridge. And as I mentioned before, I get to provide staff support. In the past, other members of the faculty have served on this committee. And they take their responsibilities very seriously, and they hope against hope that they never have to have a meeting. But if they do have a meeting to deal with an allegation, then they go at it with a considerable amount of energy and, but at the same time, discretion, because allegations of research misconduct are potentially extremely damaging, and they can be damaging both to the individual against whom the allegation is made, and also incidentally, and one would hope this would not be the case, but people being people, it sometimes is against the individual who makes the allegation. I have to tell you that allegations of research misconduct should be made, they can be made anonymously. There is no need for the person who is making the allegation to identify themselves. If they are afraid of the possible repercussions, then they are perfectly free to make these allegations anonymously. However, it really would be nice if someone were to make such an allegation to be as specific as they could be, because just to say, oh, Joe Blow is a crook, really doesn't advance our understanding of what might be at fault here, and doesn't give you really a handle to work on. So if an allegation is made, it should be in sufficient detail to allow us to meaningfully look into the issue. Allegations should generally be in writing and can be directed to any or all of the members of the committee or to my office. And if the allegations are not made anonymously, and sometimes it's real difficult to be anonymous even if you choose not to sign your name, because there's a limited number of people may have access to the information that's being discussed, efforts will be made by the institution to protect the confidentiality of the accuser. You have to know this, that this is institutional policy. If we receive an allegation of research misconduct, the first thing that we have to do is an inquiry, and the inquiry is a kind of a fact-gathering exercise. It's not intended to come to a final conclusion, but just to see if there is any basis for proceeding further with the process. It will be an initial review of the circumstances surrounding the allegation. It has a limited time frame to complete the inquiry, 60 days as defined in the regulations. And it will collect and evaluate data which could include taking possession of data, notebooks, etc., to ensure the integrity and safety of the data, and to prevent manipulation, or at least the implication that there might be manipulation of the data. So, for example, if somebody says that Joe Blow is faking the results of his experiments, and his lab notebooks show where he's been making the numbers up, we might very well go and ask Dr. Blow to provide us with those notebooks and any other raw data that is associated with the experiment. And if necessary, we are permitted to go and take them, because from an institutional point of view, the data that is generated as a result of research conducted under grants and contracts awarded to REI belongs to REI and not to the individual investigator. So what we will do is we will go and we will request them, and if necessary take them and place them out of the reach of the person who is the accused, and out of the reach of anyone else who might have a desire to manipulate the data. And this is intended to do two things. One is to protect the integrity of the data as it stands when the allegation is made. It also protects the accused, because the accused cannot be then accused later on of fudging, trying to fix it in the time that we're doing the inquiry. And we have in the past done this. And I can't go into details, but we have done that, and it has allowed us to be very clean in our inquiry. No one can come back to us later on and say, yes, but Joe Blow had plenty of time to fix things. We go and we take the data and we quarantine it. If the inquiry comes to the conclusion that there is enough evidence to proceed, then we have to go into an investigation phase. And I said 90 days, actually we have 120 days. The investigation will be conducted either by the same group or perhaps by another group if it's felt that special expertise is required. They have 120 days to review the allegations and to evaluate, and at this point they're actually making a decision, is this wrong or is this okay? They may, if they have to, interview individuals with special knowledge, such as the accuser, if the accuser's identity is known, such as colleagues of the accused themselves, and they ultimately have to arrive at a final judgment regarding the merit of the allegation. And this is where the preponderance of the evidence standard obtains. They are not there to decide beyond a shadow of a doubt that such and such a thing happened, but they have to feel that there is a greater probability of it having happened than not. And that is their standard of proof. After the investigative stage, they have to prepare a final report for REI administration. and then turn that over to the REI administration with suggestions for penalties and remedies and so on and so forth. Equally, if the charges are found not to be valid, then it becomes important in that case to be willing to take steps to repair the reputation of the accused. And although one might very well take extraordinary measures to protect the identity of both the accuser and the accused, these things have a way of getting out. And it becomes important that the accused, if the evidence does not support the allegation, the accused be offered remedies to allow their good name to be restored. But let's say the accused is found by the preponderance of the evidence that they appear to have engaged in research misconduct. The ultimate responsibility for taking action falls not to the investigative committee, but to REI administration, which has the responsibility to review the report and take action as necessary. They have the option of implementing the recommendations of the investigation. They may have to, if there's federal funds involved, they may have to report the results of the investigation to, for example, NIH. And in the event that the allegation is sustained, they must take steps to protect the whistleblower. In the event that the allegation is not sustained, they must take steps to repair the reputation of the accused, and, I might add, protect the whistleblower. One of the unfortunate consequences of blowing the whistle on somebody is that even if you are proved wrong, whether you're proved wrong or proved right, you will often suffer the consequences of having blown the whistle. Nobody likes a snoop. But REI, as with all other institutions, has to have in place ways of protecting the whistleblower. You cannot fire someone for making an allegation, even if it proves not to be borne out by the evidence. People should be encouraged to bring their concerns to the attention of independent and unbiased observers. And one of the unfortunate consequences of a lot of cases is that the whistleblower ends up getting punished. But REI is committed in its assurance to preventing that from happening. So that's a kind of a cook's tour of how to go about committing scientific misconduct. That's the rules about what constitutes scientific and research misconduct, what the operation is if such an allegation is made, and what the consequences are. And I hope that if there's a few minutes, if anyone has questions, I'll try and address them in the remaining few minutes of the presentation. Thank you.